Welcome back to Lean Design Unit 7. Today we're going to talk a little bit about 3D design. In the class we'll actually make a visit to the 3D printing studio. Talking about 3D printing as a key tool in rapid prototyping is essential to the lean design process, because now we can not only create prototypes quickly, but we can also manufacture products, short runs of products, very quickly and efficiently. Just a reminder, a thought to take away. Lean design is about optimizing your resources and time to market. We have to be really smart about how we do things, where we do things, what we spend on the development of our products. So efficiency, optimizing, consideration of limited resources. That's what this course is all about. That's what lean design is all about. One way to optimize the production of the creation process is through the use of 3D printing and 3D printer objects. 3D printing is a function that's accomplished by using additive processes, that we layer on elements of plastics or materials and build them up to create a product. You can look at it as thin slices of material stacked on top of each other to create an object. That's the basis of 3D printing. There are really two types of 3D printing. One is FDM or FFF. That is a thermoplastic, like a PLA or an ABS material that's fed into an extruder, melted, and then layered onto a hot plate and kind of stacked up to create the product. As it cools down and hardens, it creates the product or the prototype. The alternative is the SLA, stereolithography. Instead of extruding the material out of the hot end, this one uses a laser or a projector combined with a resin to kind of burn the material into an object. The objects are printed in Nevada resin, and as a laser or the other lighting source slowly cures material within the vat, it creates the product. So we have FFF or FDM, which is the melting, and then stereolithography, SLA, which is using a laser shot into a vat of material. 3D printers have come way down in price. Again, it's a basic hot plate with an extruder with some filament being fed in, melted, and extruded onto the hot plate. You can buy a 3D printer today anywhere from $500 to $15,000. You can spend more for a commercial version, but for a basic studio type novice 3D printer, you can get a cheap little MakerBot or a imported 3D printer for between $500 and $1,000. You get a fairly nice one. You can spend, again, up to $15,000 for studio quality ones. The difference is actually in the height and width of the heating tray. Listed at the bottom a number of some of the more popular 3D printers. There are tons more, and every day it seems like there's a new printer coming on the market. In our 3D studio, we use a lot of MakerBot and Formlab units. I think they're starting to steer away from MakerBot a little bit, but it really doesn't matter. It's a hot plate with an extruder, and then again, the big differentiator is the size of the object that you can print within the device. The other consideration is what's called a filament. It's the material that's extruded, heated and extruded. Filament goes for about $10 a pound, $20 for a roll of just over 2 pounds. Comes in all different colors. And I should point out, only certain printers will do colors. Some printers are single color. The more expensive printers will do multicolor. The way it works is you have a software program, you write the code, or you can actually borrow images or shapes and combine the shapes to create a product. That software then talks to the printer, which then melts the filament onto the hot plate and stacks it up in the shape, whatever shape is dictated by the software. A consideration when you're doing prototyping is the density of the material. People ask me often, how much does it cost to do a 3D printout? Well, it's a function of the size of it and the density of it. If it's solid plastic, it's going to take a long time to print it. It's going to use a lot of material, and you're going to need a special printer to do it. So what you try to do is optimize your design to use as little material as you can and keep the size relatively small. Just a lot of considerations. The folks at the 3D Lab can certainly help you with this. Anybody that's familiar with 3D printing can advise you on the best designs, the best printer, and the best materials to use. There's a ton of software. A lot of it is free. I've highlighted the free software in green. Some more sophisticated than others. Some are browser-based, and some you can download. You have to be a little bit careful. I have downloaded some of the free software, and it brings baggage with it. So before you download it, you want to just make sure that there's not a lot of stuff attached. I think my favorite one is Tinkercad for a free product, and SolidWorks and AutoCAD obviously are really, really good programs, but they're expensive. We do have access to SolidWorks and AutoCAD at the university, but individually, for your personal use, Tinkercad is free. It's got hundreds of thousands of objects that you can put together to create products, so they do a lot of work for you. Most of them are pretty easy to use in modeling software. What I don't talk about in this presentation is there is a accessory product, which is a scanner product. It's a little turntable with a couple cameras. It's available. It costs about $1,000. We do have one in the 3D printing lab that you can use. It's kind of cool because you can actually scan in an object and have it translated into 3D software. And from there, you can then actually replicate whatever you scanned in and print it out.
3D printing technology is already changing the way we produce objects, from tools and toys to clothing and even body parts. 3D printing is part of a process known as additive manufacturing, where an object is created by adding material layer by layer. Additive manufacturing allows designers to create complex parts for machines, airplanes, and cars at a fraction of the cost and time of standard means like forging, molding, and sculpting. Now, smaller, consumer-friendly 3D printers are bringing additive manufacturing to homes and businesses. The first step in 3D printing is to create a blueprint of the object you want to print. You can use modeling software like Blender to create your own designs, or you can visit websites like Thingiverse or Shapeways to find objects other users have 3D modeled. Once you have a finished design, it's time to send it to the printer. Some printers, like the MakerBot Replicator 2, have renewable bioplastic spooled in the back of the device, almost like a string. When the printer receives the data, it pulls the material through a tube, melts it, and deposits it to the plate where it instantly cools. As you can see, the 3D object is created through layering, where the printer will add one layer of the object at a time until you have a fully formed structure. The most common material used in 3D printing is plastic, but the use of some other materials allow for the creation of some pretty amazing products beyond simple tools and toys. 3D printing food is becoming very popular, and additive manufacturing has allowed for the creation of some pretty intricate treats. In the medical world, doctors are testing biomaterials for regenerative medicine. By using a patient's cells, doctors could 3D print small body parts like ears and noses. Some surgeons have even tested 3D printed organs for transplants. Recently, giant 3D printers in China printed 10 houses in just one day and at a cost of less than $5,000 per house, proving just how cost and time efficient 3D printing can be. For more on 3D printing, check out Mashable's latest coverage. And don't forget to watch the other videos in our Mashable Explained series.
Another video I'd like you to watch. This is one of the current concerns with 3D printing. The accessibility of
this is a plastic 3D printed gun.
Can be misused.
3D printed plastic.
Plastic gun?
Yeah. Mixed emotions on
made?
this one. This is
Yes.
a fellow that printed out a 3D gun.
It might work, it may
it'd
not.
be worthwhile
Hence
to
down
watch
here.
this
If you made it, please don't shoot it
reflect
here.
on the
Okay.
implications of 3D tools and actually some of the new technology that's becoming available to us, how it can be misused. So the link is on the bottom. This is about a 3D printed gun. I'd ask you to watch this video.
My name is Cody Wilson. I'm the director of Defense Distributed, and we print gun components with 3D printers. And one day we want to print guns. One, in the United States, it's always been legal to make your own gun. You know, it's always been. People don't do it because, well, what's the last thing you made for yourself? You know, you go buy it. And it's still legal to make your own gun outside of commerce. Literally, all the things that these people are afraid of were already legal. We're just providing you a direct way to do it and saying, yeah, why not? We really don't think politics is possible in a traditional sense, like a real sense anymore after the Cold War. It's boring. It's not possible to do anything anymore in this world. Events have stopped, you know. So we're always looking for something just, you know, to not only to fulfill us, but just to feel like, okay, you know what, the world isn't such a terrible place. Events can happen again. And we came up with, okay, you can print a gun. That's a cool concept. But it's much cooler when you give it away. When you take a page out of open source and the hacker and maker movements, you make it political, you stir it up, right? You've got a potent little mixture here. And it's something the world thought was potent as well, I suppose.
Alright, this is the basic Liberator. You got your receiver right here, barrel, internals, and handle. Normally you use plastic pins to put them all together. I've been using metal ones since that makes them a little bit more reliable. I don't have to worry about those as much. My name is Travis Larrell. I'm a 30-year-old prior Air Force software engineer. And just got into all this stuff because it seemed fascinating. AR-15 lower, AR-15 magazine, TARDIS with a drawer system that I grabbed off Shapeways and started messing with. It's from Doctor Who. Oh, and 3D printing was in its infancy. I mean, printing a single non-static piece was very easy. It doesn't have to work with anything else, so if the size is a bit off, it doesn't really matter. But as things got better, people want to immediately see how far they can push it. Guns had that mix of controversy and challenge that I think attracted a lot of people to that. I used the Cube. It cost me about $1,300. The whole Liberator took about 2 days to print. Probably $20, $30. I got it directly from DefCAD, pretty much right after it was released, so the whole ITAR thing hadn't been an issue yet.
So I'm a law student, right? A lot of the research was, can we do this the way we want to do this? And what is the legal way of doing this? We've only just begun to crack some of these legal problems. But right now, we want at least a shot at it. So we have to comply.
I'll take some spare in case I break them. All right. We're off to the gun range to give the Liberator its first test. Maybe it'll fire, maybe it won't, but as long as it doesn't take my hand off, that's the important part.
Part of the project is at least demonstrating, okay, that the law is in places, not this grand encapsulation that it was thought to be, and built up through the whole 20th century, right? You know, post Sandy Hook, it was like, we're almost there if we can just take the semi-autos away, you know, to find out that actually, you know, the back door is getting blown off. And in fact, you've got a whole bigger problem heading your way.
Literally millions of people, I think, at this point have downloaded it. So the amount of files that are out there is so large that it's accessible to anyone who wants it.
I'm not willing to go all the way to say I'm providing you a gun. Well, we're blending, to use the Pirate-based terminology, there's a physical quality to this. So it's more than information, right? But it's less than an object. It straddles the line.
If you want to shoot it off once or twice, I'll gladly walk
Okay.
back.
I'll walk back.
We'll
That's
gladly
entirely
walk
fair.
away.
Yeah, I'll let you know before I shoot it. Then 3D printers are often subtly different, so you get a model from somebody else. It may not print on your printer at all, or it may require modification to print correctly. There's definitely a learning curve to it. Yeah. It is not firing, so I think I'm done with it.
All right, good. So you're done, right?
Yes.
All right, good. Thanks.
All right, we tried it a few times. It was dinging the primer, but it's not going off. It looks like the primer is not taking enough force to actually explode reliably. So I think I'm going to improve the firing mechanism and replace it with a more traditional, like, cylinder striking pin. All right, it should be the basic shape. That's the process. It's never perfect the first time. You make a new one, give it another shot, and just keep going until it gets better. I think that other people could definitely do it. Being familiar with computers certainly helped me, but it wasn't specifically a programming task, so I feel like anyone could do what I've done.
One of the things I worry about the most is that people actually enjoy the pleasurable modes of subservience that they get from watching TV and watching politics as a spectator sport. They don't actually want to be political. They don't want to have control over their affairs. It's easier to have everything organized for you. And in fact, giving you the means to produce a gun for yourself, while that might sound revolutionary, is in fact not very interesting to most people. So for me, it's not, well, what's the future of 3D printing? For me, it's, can I activate someone politically? How can I do this? And what's the most potent, symbolic way of delivering what I think is an essential message, which is that, okay, you know what, human liberty is something that you have too. Defense Distributed, Austin, Texas.
The Liberator itself probably won't have a huge effect because it's a very early gun in this. But I imagine that I'll see future designs built off the Liberator that will be better in many different ways. You put enough minds to work on something and someone's going to come up with something interesting.
There's no stress failure point here anymore. There's just nowhere for it to fail in this setup.
Right.
I don't have an end game. I don't know where this project ends. Some people can have this information, some people can't. That's interesting. Why is that so? Do we really believe that? Is that just? Is that equitable? You know, not as just and equitable as it could be. And thus Defense Distributed.